All right, I'm Matt Sitter, this is Alex Brodsky and Alex Gerard, and as Professor Curry said, we did a PC-based acquisition and data recorder system. And our requirements were that we had to read in 12-bit signed integers from a USB device, which we used just a microprocessor to do that. And from there, we had to then plot them on the screen and try to get the speed as high as we could. Our initial goal was to be graphing 30,000 points per second. And we can also graph 1, 2, 3, or 4 channels of data at the same time with varying speeds.
And I was in charge of creating the test data source. I used an AT-MEGA88 microcontroller. I used 2 button interrupts. One was for changing the channels, 1 through 4, and one was for changing the data speed. And I also used the Windows documentation to create a PC client to read serially from the USB serial converter. So we used a protocol that for me to send data and Matt to understand, because we were sending 12-bit data points. The challenge in this was with the USB serial converter, USB to serial converter. I had to shift all the bits left 1, I had to flip all the bits, and when I did this I was only able to send 7 bits per byte, so there were a few problems with that. But we didn't really have to change anything with our expected protocol, which was good. So for each 12-bit word, I had to send 3 bytes. One was for the command, which I started with 0, 1. The next 2 bits were the channel, either 0, 0, 0, 1, 1, 0, or 1, 1 for channels 1 through 4. Then there's 4 bits left over for our data rate, which right now I'm sending 4 different data rates, but it's open to have 16, so it's user selectable and can be changed very easily. The next 2 bits start with 0, 0. One's the most significant byte, which is 6 bits. One's the least significant byte, which is another 6 bits. And together that equals a 12-bit word with a channel and data rate. Also, with the USB to serial converter, after the most significant bit and the least significant bit, or after the command and the most significant bit, there's a stop bit sent. So that makes a total of 5 bytes per each data point. So like we said earlier, one of our original requirements was hoping to reach 30,000 data points per second. What happened though, we can send a 16-bit baud rate, which is the highest we can be is at 65,535. A baud rate is how many bits we can send per second, so that's 7,500 bytes per second, and we're doing 5 bytes per word. So our maximum was 1,500 12-bit words per second, which was as far as we can push, and that's 1 word every 667 microseconds. And one of our requirements also was that we can send data at channel 1 faster than channel 2, faster than channel 3, because we're sending only 1 channel for 1, so we hit our max speed of 1,500. Channel 2, we had 2 channels running, 1,500 total points, 750. It divides down like that. So there's 375 points on 4 channels when we sent 4 channels.
And then from there, my goal was to read in the data points from the USB buffer. And as Alex said, we had to read 5 bytes from the buffer to include the stop bits. And so that slowed down our graphing significantly because it took more time to read the points in. And to increase our speed some, we multi-threaded our program. And we have 1 thread running to do the graphing, 1 thread running to convert the data points, and 1 thread running to read them from the buffer. And my goal, or my task, was to first determine which channel the point was coming in on by using the command byte. And that would also tell us what the speed that the data was being plotted at was. And then after that, I had to get the most significant bit and least significant bit, and I would have to shift the most significant bit and add them together to get our 1 data point. And then we had 4 different queues, 1 for each channel, and I would store the points in the appropriate queue. And whenever we were graphing the points, if we were graphing slower than the data points were coming in, I have to average out some of the points so that we can plot all of the points and not be having just way too many points to graph. And then if we're graphing faster than the data is coming in, I had to interpolate the data, which I accomplished using timers to figure out the time between 2 points that were received by the USB buffer, and then also to figure out how many points I had to provide between those two.
Okay, so my part of the program comes in by taking the data from the queues that Matt is putting his data into, and graphing it. So I start off by initializing the user interface, which consists of initializing the DirectX 11 objects, and then initializing the menu widget, and then basically just goes into an infinite loop that checks if, first checks if a user's been pushing anything or anything, and then if not, it just renders it each time, and basically just takes the newest data from the queue that Matt's been putting in, and shifts over all the old data to make it scroll. Then here's kind of the menu functionality we got. Turning the channel on and off, changing the color, changing the scale of the horizontal and vertical axes, recording data points to a file, and playing it back.
So the results of our project went as follows. Initially, we were shooting for 30,000 data points per second, and that was kind of just a roundabout goal. What we were actually doing was trying to push the PC as fast as possible. And what we found out was, after calculating, our maximum speed would be 1,500 data points per second. And that is what we're hitting. But after adding multiple channels, we decided to focus on our first prototype showing we were very jerky, it wasn't very smooth. We felt that was the most important thing before really getting 1,500 points on. And now we're hitting our maximum speed while graphing as smooth as possible, so we're very proud of our results.
Some of the challenges that we came across, Matt had some real difficulty. The interpolating data was a challenge for us that we had to work together for. And then me rendering at a constant speed each time when the user might have been interacting with the menu or something. And then just graphing smoothly as possible in general with everything working together was a challenge. And as Matt said, the reading from the USB buffer took the longest time, which kind of had to slow down everything else.
And then we can also show you our program running right now. It might be easier just to hold the laptop up and plug it into the projector. It slows down some.
So this is our program right now running with 4 channels. There's just kind of a triangle wave going on. You can see it's smooth. It's hitting every point from negative 2048 to 2048, which is 12-bit signed words. There's a few other functionalities. Done. This is gross. Do you want to try doing the menu? Or?
Sorry, I think it's fine.
All right. Well, that's what it does. Do you guys have any questions about it?